Hi everyone, welcome back to the Foundry by Forge College. Let's just jump right in, because today's explainer covers something that literally separates the amateurs from the absolute pros in Web3. We're talking about environment isolation and safety. If you remember our last lesson on configuring network parameters, you know we're deep into Solana deployment strategies right now. So grab your notebook, because we are going to engineer a system that protects your code from the ultimate variable, human error.
Let me ask you a question. Have you ever accidentally tested on mainnet? Look, we've all heard the horror stories, right? You've got a developer who thinks they're pushing a totally harmless test transaction to devnet, but oops, their environment variables got crossed and boom, they've just executed on mainnet. They're burning real sol or even worse, dropping a production database. It's the classic developer nightmare that wakes you up in a cold sweat. Well, today we're making sure you never, ever have to experience that sinking feeling. So tying this back a bit, in our previous explainer, we covered configuring network parameters. And you can think of network parameters like getting the correct GPS directions to a bank. You know the route, you know the address, right? But hey, just knowing the address doesn't mean you should be allowed to just waltz right into the main vault and start moving things around. That is exactly where isolation controls come in. These are the strict, unbending rules and security checkpoints that dictate exactly what actions are allowed once you arrive, and how mistakes are contained if somebody takes a wrong turn. Okay, so here is our structural blueprint for constructing this safety net. We'll start with the whole test and production nightmare, then we'll cover fail-fast guards, map out our deployment environments, and look at separating secrets from configuration. After that, we'll build a recovery time machine with rollbacks and audits, and then finish up with a quick recap. Let's get into it.
Section 1. Test in production, otherwise known as the ultimate nightmare.
Right, so environment isolation, what is it? Basically, it's the strategic separation of networks, data, and credentials to prevent cross-environment impact. Honestly, think of it like building a massive, heavily reinforced physical fence right between your chaotic DevNet playground and the high-stakes mainnet highway. If a car spins out in the playground, the fence ensures it never, ever crashes into the highway traffic. That's the fence we are building today.
Moving right along to Section 2, fail-fast guards, your automated safety nets.
So a fail-fast guard is a testable function that detects misconfigurations early and, well, it fails loudly. I want you to kind of anthropomorphize your deployment script for a second here. Your code should act like an overly dramatic alarm system. If an RPC endpoint looks even slightly suspicious for the environment it claims to be in, your code shouldn't just log some quiet little warning. No way. It should sound the sirens, lock the doors, and crash the process immediately. It takes your good human intentions and transforms them into mechanical, enforceable safety. So how do we actually build this dramatic alarm system in a language like TypeScript? It's basically a three-step logic flow. Step 1, assert the RPC URL is actually present. If your config forgot it, fail right then and there. Step 2, detect if the word mainnet or mainnet beta is hiding anywhere in that URL string. If it is, and your environment isn't officially tagged as production, we trigger Step 3, which is requiring an explicit allow production equals true flag. It literally demands explicit, deliberate confirmation before it ever touches a production network. Guys, it's the digital equivalent of turning two keys simultaneously to launch a missile.
All right, on to Section 3, environment mapping, where we draw those strict boundaries. Just look at how the security controls scale up as we draw these strict boundaries for each environment. Over in your local environment, you're just using simple local developer keypairs and manual rollbacks. No big deal. But as you move to the right across to CI and staging, you start introducing scoped permissions, central vaults, and automated redeploys. And then finally, in production, the rules are absolute. Mainnet RPCs only, hardware security module-backed vaults, production-only keys with multi-factor authentication, and pre-approved rollback runbooks. You never ever mix the columns. A local dev keypair should physically lack the ability to authenticate anything in staging or production, period.
Next up is Section 4, secrets versus config. Keep them separated. I really want to make this as clear as possible. Configuration templates, they are just environment references and pointers. They're telling you, hey, the database is over there, and the API key is called API_key_prod. Secrets, on the other hand, are the actual sensitive keys and tokens. Configuration dictates where you go, but secrets dictate what you can actually do. And your real keys should absolutely never, ever be hard-coded into your configuration templates. Think about it. If someone steals your blueprint, they shouldn't automatically get the keys to your house, right? To enforce this separation, we use what's called a secrets backend. This is a dedicated, isolated store, like a central vault or a key management service, that securely holds credentials completely away from your application repositories. By referencing a secret's backend instead of pasting tokens directly into your code, you entirely prevent those embarrassing accidental leaks on GitHub. Plus, it makes credential rotation practically effortless. If a key gets compromised, you just rotate it in the backend vault once, and boom, all your environments instantly pick up the new key without a single code change.
Which brings us to Section 5, Rollbacks and Audits, Building Your Recovery Time Machine. Here is exactly how we build a flawless recovery system across the deployment timeline. Let's walk through it. Point 1, pre-deploy. You create an immutable artifact. The code is frozen. Point 2, you deploy, but you tag a database snapshot right at that exact moment. Now, let's say point 3 happens. An incident, an error slips through the cracks. Because you have a strict audit event log, you know exactly what changed and who changed it. And that allows you to smoothly transition to point 4, recovery. You simply execute your rollback runbook, reverting straight back to the snapshot and that immutable artifact from point 1. By keeping immutable artifacts, you're basically turning a panic-inducing, catastrophic error into a calm, repeatable, and honestly, kind of boring recovery process. Okay, but how do we actually enforce all of this? The answer is CI gates and checks. As we emphasize in so many of our comprehensive learning programs here at Forge College, embedding these checks directly into your CI/CD pipeline makes safety an automated guarantee rather than just relying on tribal knowledge. Your linters should automatically flag hard-coded URLs. Your validator needs to mock environment loads to ensure templates resolve correctly. You must require cryptographic signatures or explicit human approvals for any production pushes, and every single one of those approvals, they must be edged into your audit logs. Safety has to be mechanical, guys.
Finally, Section 6, Conclusion and Recap. Let's look at the key takeaways.
All right, let's summarize these core takeaways really quick. First up, keep secrets entirely out of templates by using dedicated secrets backends. Second, validate your RPCs with those dramatic fail-fast guards we talked about. Third, enforce all these rules mechanically in your CI pipelines. And finally, maintain immutable artifacts and snapshots so you can have reliable, stress-free rollbacks. Mastering these principles prepares us perfectly for our next phase in this curriculum, which is packaging these isolated, safe environments into reusable deployment scripts.
I want to leave you with this provocative thought to ponder as we wrap up. Are your deployment scripts just executing commands blindly, or are they actually enforcing safety? Because a truly great script doesn't just do what you tell it, it stops you from doing what you shouldn't. Thank you so much for joining me for this explainer. To master more Web3 topics and continue building your skills with our structured courses, make sure to visit forge.college. Keep building, keep isolating those environments, and I'll catch you in the next one.